Good morning, everyone. Myself, Devika, working as assistant professor in the department. So, overview, defining the bus bar and its role, uh, then identifying common fault causes, choosing the right protection methods, and criteria for selecting CT ratios, and various fault classifications, then strategy to resolve the faults, and understanding dot convention and polarity indicators, and advantages and explanation of stability ratio, then bus bar protection schematic for MRSS, then reasons for excluding bus bar protections, and insight into pilot wire supervisions, and summary and final thoughts, and references and sources. So, what is bus bar? So, the term bus originates from the Latin word omnibus, meaning for all. So, it serves as the central hub in on electrical power systems. So, acting as the key junction where multiple circuits converge and interconnect. And causes of faults. See, insulation failure triggered by excessive voltage such as intrusion of foreign materials and signal factors. So, gradual deterioration of insulation quality due to aging, corrosions, exposure to saline environments, and other degrading influences. Types of faults. So it can be generally divided into two main types. One is external faults, another one is internal faults. So for effective unit protection, the differential protection scheme must be designed to detect and react only to internal faults. So it is crucial that the scheme remains unresponsive to external faults to avoid unnecessary trippings. Appropriate protection methods. So the differential protection is used to protect the bus bars. So why choose the differential protection? The system's terminals are positioned close together. So by placing current transformers on both ends of the bus, it's possible to compare the incoming and outgoing currents. So any discrepancy between these currents instantly indicates on internal fault within the bus. So this current difference energizes the coil of a differential relay through the current CT secondary circuit and triggering strip signals to the circuit breakers on both sides to promptly isolate the faulty section. So we have to protect the bus bars. Requirement of bus bar protections. So high speed and reliability and stability during external faults. Then bus bar protection methods. So these are the protection method techniques for to protect the bus bars by using differential protection, overcurrent protection, and frame leakage protections. Differential protections. So it works based on the Kirchhoff's laws, Kirchhoff's current laws. So we know that the sum of entering current is equal to sum of leaving current. Uh, the Kirchhoff's current law states that sum of entering current is equal to sum of leaving current. So in normal conditions, sum of currents is equal to 0. That means I1 is equal to I2. So the relay is inactive. So when a fault, so there is no fault, so no current difference. The relay is inactive. So whenever occur a fault means the current difference is occurred in I1 minus I2. So the relay trips send a signals to the circuit breakers. The circuit breaker the disconnect the circuit. So we have to protect the bus bars. Advantages. So it fast and accurate and reliable. So the disadvantage of differential protection is costly and complex. Protection of transmission lines. So introduction to transmission lines, it carries power over long distance and it exposed to environmental conditions. Types of lines faults. We know that we have classified single line to ground fault. So it is most common faults, and then line to line fault, double line to ground fault, and three phase faults. Causes of line faults, causes by lightning, tree contact, and equipment failure, and the weather conditions. Protection requirements. So the importance role is selectivity of the relays and speed and time, sensitivity and reliabilities. Overcurrent protection. It is a simple method and it used for short lines. Distance protection based on impedance measurement, so it's suitable for long transmission lines. So distance relay zones, zone 1, zone 2, zone 3. So in zone 1, instantaneous instantaneous active relay, zone 2, time delayed relays, zone 3, backup protections. Differential protection of lines. It compares current at both ends, so it requires communication channel. Carrier current protection. It uses communication signals and high speed protections. Advantages: fast fault detection, accurate. Disadvantages: expensive and requires communication systems. Application: it is used in power transmission networks, substations, and industrial systems. Conclusion: protection ensures system safety. So bus bar, we have to use the differential protection to protect the bus bar, and distance protection used for transmission lines. These are the reference for further study. Thank you.